Now I'm going to introduce another shape called a frustrum. So frustrum is like a piece of solid enclosed between two parallel planes. So over here this is a frustrum. Let's call this R1. Let's call this R2. Sorry, my drawing is not perfect. Let's call this entire thing L, and let's call just this thing D, and then this over here is L minus D. So I want the surface area of just the frustrum. Surface area of the frustrum only would be lateral surface area of the large cone minus the lateral surface area of the small cone. So that would be pi R2L minus pi R1 L minus D. R2 is the largest. So wait. D. R1 R2. Now I have this surface area, but I only want it in terms of R2, R1 and D. I don't want any L over here. So what I can do is, since let's say we have a cross section of the cone R2, R1, and all this is L, and this part this part is L minus D, this part is D. And since the radius is proportional to the slant height, I can write R2. So R2 over L should be equal to R1 over L minus D, since the radius is proportional to the slant height. Which means right? I hope I'm right. So L is D times R2 upon R2 minus R1. Now going back to the surface area, I can replace L, right? Surface area is pi D R2 squared R2 minus R1. Then I can replace this L minus and dr1 I can do this. Wait a minute. Whoops, I forgot D here. Right now I can take D out. And this is going to be annoying. So I can multiply d is outside, and I can multiply these two. And I can separate the fractions as well. r1 squared r2 minus r1, right? And then this and this cancel out. r2 squared r1 squared r2 minus r1. Now, so j plus k times it by j minus k. Like I'm just showing you something and then I'll get back to this. This gives j square minus jk plus jk. K minus k square. Which means j plus k, so j square minus k square over j minus k. That this makes sense, right? So going back, I can write it like this: pi d and both the radius. This is the lateral surface area of a frustum.